Welcome to Polytechnic Seberang Perai. We are from Jabatan Kejuruteraan Elektrik and will present the video about digital electronics, Introduction to Logic Gates. First, let me introduce our group members, which are Puan Noraini, Puan Nur Hidayah and me, Puan Norsalina. We hope that this video will help you to gain some knowledge regarding this subtopic. The application logic gates in traffic control signals provide for an orderly movement of traffic. They help reduce the frequency of an accident of some special nature, such as right-angle accidents. In addition, they intercept heavy traffic to allow other traffic to cross the road intersection safely. First situation. This road has a problem in its traffic system. It can make an accident happen. This situation can be solved by using logic gates in the traffic system. Second situation. This road has a good traffic system. This situation happens because of implementation of logic gates in traffic system. It means that in any situation when input is more than one, we can use logic gates to control only one output selected at the end. So the situation will be safe for everyone and more comfortable for everybody. In this video, we are going to discuss the logic gates and their type. There are three major classifications of logic gates. The first one is a basic gate, which we have AND, OR and NOT gates. Next is the universal gates, which is NAND and NOR gate. And we also have the other gates, which is XOR and XNOR gates. Each of these gates has specific symbols and behavior. Logic gates are what we use to create digital logic circuits. They are the building blocks of any digital system. They take one or more inputs, perform a specific function, and then produce an output based on that function. For further understanding, first we have to see the relationship between the input and output of the logic gates. The input will list all possibilities of input binary variable. The output will match the output to each of the input. Let us consider a logic gate with single input A. It can take a value 0 or 1. There are two input combinations for one input variable. Next, consider a logic gate with two inputs, which are A and B. It can take a value of 0 or 1. There are four input combinations for two input variables. Now, how do we decide the output? The type of logic gates will decide the output. The first type of logic gate that we are going to discuss is the NOT, also known as inverter gate. This is the symbol and the logic expression of NOT gates. This gate has one input, X, and one output, Z. This expression is used to determine the output. Suppose we look at the truth table. NOT gates will give output 1 when the input is 0 and output 0 when the input is 1. So basically, it will give the opposite. The timing diagram illustrates how the output responds to the input. Next, we have the AND gates. The symbols and the logic expression is shown. This gate has two inputs, X, Y, and one output, Z. As we look at the truth table, the output of AND gate is 1 if both inputs are 1. Otherwise, the output will be 0. Next, we have the OR gates. The symbols and logic expression is shown. This gate also has two inputs and one output. Again, look at the truth table. The output of the OR gate is 1 if one of the inputs are 1, else the output will be 0. Next is the NAND gate. NAND gate is designed by combining the AND and NOT gates. The symbols and logic expression is shown. The output is 0 when both the inputs are 1. Otherwise, the input will be 1. Basically, the output of NAND gate is obtained by complementing the output of the AND gate. Next is the NOR gate. NOR gate is designed by combining the OR and NOT gates. The symbols and logic expression is shown. The output will be 1 when both the inputs are 0. Otherwise, the input will be 0. Basically, the output of the NOR gate is obtained by complementing the output of OR gate. XOR is the short way to say exclusive OR. The symbol and logic expressions are shown. Like OR, XOR also needs one input to be 1 to get output 1. But unlike OR, when both of the inputs are same, it will give the output 0. XNOR is the short way to say exclusive NOR. The symbol and logic expressions are shown. XNOR has the same symbol as XOR except it has a bubble. The output is 1 when the inputs are set to both 0 or 1. Basically, the output of XNOR is the complement of the XOR gate.
Now let us see the simulation for AND gate. First, let me introduce the component used. The components are power supply 5 volt, breadboard, switch X, switch Y, LED switch X, LED switch Y, LED output Z, IC 7408 for AND gate, and 3 resistor. Now, when the simulation is on, first, switch X equal to 0. LED switch X off. Switch Y equal to 0. LED switch Y off. So the LED output Z is off. Next, switch X equal to 0. LED switch X off. Switch Y equal to 1. LED switch Y on. So the LED output Z off. Then switch X equal to 1. LED switch X on. Switch Y equal to 0. LED switch Y off. So the LED output Z is off. So the last one, switch X equal to 1, LED switch X on. Switch Y equal to 1, LED switch Y on. So the LED output Z on.
In digital, high, which is 5 volt, represents logic 1, while low, which is 0 volt, represents logic 0. If the switch is closed in this circuit connection, logic 1 and the current flow, so the LED on. Meanwhile, if the switch is open, which is logic 0, and the current cannot flow, so the LED off. This video is presented by Jabatan Kejuruteraan Elektrik Politeknik Seberang Perai. We hope that this video will help you to understand more about the basic logic gates. Thank you.